Welcome back to our series on probability theory. I'm Mark Ledbetter. This is lecture video 21, and we're going to talk about the hypergeometric distribution today in this video. So in the last few videos, we talked about the binomial distribution. We introduced its formula for the PMF. We also introduced the mean and the MGF and the variance. And we derived the mean and the variance. So in this video, in this section, we're going to talk about the hypergeometric distribution, its mean and variance, and do an example. Now, there is no table for the hypergeometric function or distribution. Let's talk about how it's derived. So we have a collection of n items, and there's similar objects, but there's two categories within there. So we have n1 items, more than 0, that belong to one category. So we definitely have two different categories here. N1 or N2, neither one can be 0. They have to be, there has to be some in both categories, okay? So N1 is the number in one category or one type of object. N2 is the number of the other type of object in the collection. And we're going to select n items, and that could be anywhere from 1 all the way up to n of those items at random and without replacement. Okay, so we're going to do that without replacement and at random. Let x be the number of objects that are selected from the category that has n1 objects in it. Okay, we want to find the probability that our random variable x is equal to little x. Now little x is less than or equal to n. It also has to be less than or equal to n1, and n minus x has to be less than or equal to n2. So x can't be bigger than the sample size, and n has to be less than n1, and n has to be less than n2. And of course, n has to be less than capital N, the total sample size. All right, so there are n1 choose x ways to choose the x items from n1 objects. And there are n2 choose n minus x ways to choose the n minus x objects from the n2 category of objects. And of course, there are capital N choose little n ways to choose little n objects from n total objects. So the probability, we simply multiply and divide, right? We multiply the number of ways that we can choose x out of n1 times n minus x out of n2, divide by the total number of ways we can choose little n out of big N. And again, we have these constraints. And this is the hypergeometric distribution. And x here can be 0, 1, up to, and we have, so it can be up to n, little n, as long as little n is less than n1, but it doesn't have to be. So x has to be less than or equal to n1, and so we usually use these constraints instead of saying this for our space. So here's how we write it. X is hg n1 n2 little n. So mu is equal to little n times n1 over n. So this is the proportion or the percentage of objects that are in that one category, and times how many we select. So that makes sense as far as intuitively why that would be the mean. And then the variance is given by this formula, and the proofs are very tedious. You're welcome to see the book. I don't know if the book even does these. There's other books. I think I gave you a link to a book that we used last year, the book for actuaries by Finnan, and it has a proof, I'm pretty sure, of the derivation of these. You're welcome to look at that. So let's look at the different distributions here, what they look like for the hypergeometric distribution. So we're going to have little n, we're going to keep little n as 16 here. And let's n1 be 8, n2 be 32, And we see that we have a slightly skewed distribution to the left, right? And then here we have an equal number in N1 and N2, and we have a symmetric distribution, and that makes sense as well. Then we have N1 is again smaller than N2, and they're larger, so we have larger numbers. And let's see if we can get those. We can get those on one screen. So we see that the larger numbers are a little less skewed than the smaller numbers. And then when we have a balanced, the larger the numbers are, the more we have, then the more symmetric and the more it looks like an estimate of the normal distribution, doesn't it? Okay. So that's an introduction to the hypergeometric distribution. Don't forget to scan your lecture notes and upload them to the Google Drive that's been shared with you for the class before midnight on the date listed on the course calendar. Again, make them neat for you. You'll want to update your list of distributions with this formula and the mean and the variance. And take care. Or before we say that, if you have questions, please come to virtual office hours. If you can't make it to office hours, make sure you take a picture of both the problem and your work and send it to me. So then I can help you much better and much faster. So take care, and we'll see you next time.